In this video, I'd like to talk about the math question of the day for February 10th, 2023. And with this problem, we need to simplify this given expression and write the answer with only positive exponents. Now, to answer a question like this, you need to have a solid understanding of exponents and their properties. So you will need to understand Algebra 1 and maybe even some of Algebra 2 to be able to answer a question like this. So at this point, go ahead and pause the video, see if you can work this out on your own, and when you're ready, we can go through this together. Now, assuming that you have attempted this problem, we can start working through it together. And if you do have suggestions for future videos, please leave a comment down below. And with a problem like this, we need to understand negative exponents. So let's start with that. Let's say we have a raised to the negative b power. Now, when we have, let's say, a to the third power, this just means multiply a 3 different times since this exponent is positive. So we get a times a times a. Now, when the exponent is negative, instead of repeatedly multiplying, the negative implies we will be repeatedly dividing. So we will divide by a b times, however many that is. Or we could rewrite this as just 1 over a to the b power. So let's say we have 2 to the minus 3. This just means take this number and divide it this many times. So we need to divide 2 3 times. We get 1 over 2 times 2 times 2 in the denominator. And we can see this is just 1 over 8. So the negative exponent just means to divide repeatedly. And in general, if we had something, let's say x to the minus y, as we saw up here, basically the negative exponent just puts this base in the denominator and the exponent becomes positive. So we can start this by looking at this inner expression and ignoring this exponent. We'll come back to the exponent at the end. So let's start by just rewriting all of this inside as positive exponents. So for instance, this z squared in the numerator, we won't need to change that since that's already positive. But this y to the minus 1, we could rewrite as 1 over y since we are dividing by y one time. And x to the minus 3, we can divide by x 3 times. So essentially, if it's negative in the numerator, it will go down to the denominator and become positive. And the opposite is true. If it's in the denominator, x to the minus 8, that's really 1 over x to the 8th, but this is in the denominator. And let's say we had this separately. Let's ignore this whole expression for a moment. Let's just say we had 1 over x to the minus 8. And what you'll see is that this will end up in the numerator and become positive. But this is due to the fact that now we have 1 over x to the 8th, and we're dividing by a fraction, which remember is the same as that fraction flipped over and multiplied. So this just becomes 1 times x to the 8th over 1, which of course is just x to the 8th. So when you have a negative exponent in the denominator, by understanding that the negative exponent just means repeated division, you can go through this process where the exponential expression here ends up in the numerator and the exponent becomes positive. So let's use all of these ideas and rewrite this expression here. We can work over here a bit. Let me redraw that. And again, we're just going to replace all the negatives with positives. So the z squared will stay in the numerator since that's already positive. But this y to the minus 1, we know that's just 1 over y. That will go in the denominator. This x to the minus 8 that was in the denominator, that goes to the numerator and becomes positive. And this x to the minus 3, that's negative in the numerator, so it will go to the denominator and become positive. We have z to the 6th in this denominator, but that's already positive. Y to the 4th is already positive, and that looks to be everything. The y to the minus 1 and x to the minus 3 terms ended up in the denominator. The x to the minus 8 term ended up in the numerator and became positive. So now we've transformed this to this expression here with positive exponents on the inside, and we're still raising it to the -4, but we'll come back to this at the very end. For now, we can just simplify everything. And with simplifying this, let's isolate the variables essentially. We can focus on the x's separately, the z's separately, and the y separately. So if we had x to the 8th divided by x to the 3rd, then we can simplify this. We have 8x's multiplied together up top, and you don't have to write this out every time, but it helps to understand the rule rather than just memorize it. We have 3x's multiplied together in the numerator, and notice that 3 of them will cancel out since x over x is just 1, and we end up with 5 x's multiplied together in the numerator, so this just becomes x to the 5th. And likewise, if we had z squared over z to the 6th, let me write that out, then we can follow the same process, but in this case, we will end up with only z's in the denominator. So we have 2 of these up top, we have 6 of them down below, and 2 of them will pair up essentially and cancel out. We have 4 left in the denominator, so this is 1 over z to the 4th. And with the y's, we are multiplying here. We have 1y multiplied by 4 more y's here, and we know y to the 1st times by y to the 4th is just y to the 5th. We are now multiplying 5 y's together. So let's combine these ideas. And if you want to memorize the general rule, you can of course do that as well. If you have, let's say, a to the b over a to the c, as long as the base is the same and you are dividing, you will subtract the exponent in the numerator, the exponent in the denominator from the exponent in the numerator. And of course, that's what we saw here. We could do 8 minus 3 and we get 5 for that exponent, or 2 minus 6 and we'd get -4. But remember, 1 over z to the 4th is really just z to the -4. So we can simplify everything now. We can rewrite this expression as z squared over z to the 6th. We know that's just z to the 4th in the denominator. X to the 8th over x cubed, that is just x to the 5th in the numerator. And we know with the y's, we have y to the 1st times y to the 4th, so that's y to the 5th in the denominator. And at this point, we just need to deal with this -4 as our exponent. Now keep in mind that when you have a negative exponent and you have a fraction, you can essentially just flip that fraction and the exponent becomes positive. And again, that's because we are dividing by this expression 4 times. So in theory, we could have 1 over this expression multiplied 4 times. And when we're dividing by a fraction, it's the same as multiplying by this fraction flipped over. So we get 1 times by this essentially. And that's the process to understand it. But if you just want to remember the rule, when you have a fraction to a negative exponent, you can just flip the fraction and it becomes positive. But I encourage you to think that through on your own using basic principles. And the last step here is to deal with that +4 exponent. We have a fraction and a product here. So let's say we have a times b to the c power. When you have a product raised to an exponent, that exponent goes to both factors in the product. And it would be the same if, let's say we have d over e to the f power. If we have a quotient, then that exponent goes to each term or each factor in this quotient here. So this 4 will essentially go to each of these factors here, each of these exponential expressions with different variables. And we are raising each of these expressions to the 4th power. So we can write our final answer down here. This will become z to the 4th to the 4th, and an exponent to an exponent we multiply, so that's z to the 16th. Then we have y to the 5th to the 4th, and 5 times 4, that's 20, so we get y to the 20th. And lastly, in the denominator, we have x to the 5th to the 4th, and we know 5 times 4 is 20. So this right here will be our final answer.